Hello, this is going to be a project demo for ECE413 heart track device. So, first, this is our public DNS created from the Amazon AWS server. This is our server, so I will be attempting to log in or enter the website. So to do that, we do this and then 3000. And now we have logged in into our website for the project. So whenever you enter the website, you're greeted with the welcoming page, the index.html page. So this is just a quick overview. So we have the welcome to HeartTrack. It's basically just a project overview on what this website offers. It's monitoring your heart rate and blood oxygen saturation with IoT enabled technology. It provides you with real-time data tracking, interactive visualizations, and easy-to-use controls. So this innovative platform helps users stay informed about their health and manage critical metrics effectively. So when we're using the IoT device, HeartTrack collects all and process all the measurements, which provides the users with insights through the dynamic charts, which I'll be talking about later, and configurable preferences, whether you're at home or on the go. And the main goal is to ensure that you have access to reliable health data either at home or on the go. And below the welcoming page, you have just a brief meet the team. So we have Rashid Tamar, myself, Ahmed Malik, and Abdulwahab Al Janai. We worked on this project, and I'll be quickly going over how the website works and the front end part of it. So this is our homepage, just as I mentioned previously, and we have our references page where we talked about all the things that we used while creating the website, all the stuff that we didn't create ourselves. And now I'll take you to the login page. So we already have an account where we tested the software, the sensor. So first I'll show you the sign up feature. So this is the sign up, and let's see. So I'll be attempting to create a fake email with and see what the website responds with. So ecegmail.com. So we'll use this email without the at. The password 1234. So let's see, we sign up. It'll give you an error to include an at and tell you exactly what you're missing. So let's try again. So we have ECE at gmail.com, and then we'll have the password 123456. And now we get a message that shows you that we have registered successfully. Once you press OK, you will get a button that will allow you to go back to login. Now, let's say I want to log in ECE again without the at. It will say please include an at. Let's say if I log in with a fake username, it will give you login failed. Please check your credentials. So this is just stuff to make sure that you're logging in correctly and everything about that. So now I'm gonna log in with the account we made so I can see the data that we have. So now we log in, we get a login successful, and now we will directly be directed to your devices page. So as you can see, we have this device that we stored the sensor data on previously, and each device will have its own API key so it can be identifiable. So if we see this data, load the data. So as you can see, what we have here is a weekly heart rate sensor chart. So this chart gives you the data that you need, the weekly data that's collected from the sensor, the weekly heart rate data. And we also have a chart that shows you your daily heart rate data, and it has specific time slots where whenever you take data, it takes that into consideration and stores everything in the database. And we also have the daily oxygen saturation. This is also again measurements from the sensor daily with specific timestamps. So now let's go back to devices. You have been logged out. And now I'll show you how we can add a device. So go back to the account we just made it. We have the ECE password and login successful again. And so now we want to enter a device. So let's say we want ECE test 1. We can add a device. Again, different API key. Let's say we want to add another device. Test 2. We can add a device, and this will again show you again different API key. And now we have 2 devices. We can take different measurements, maybe 2 different people, anything like that. And now if we can go back to home, just quickly talking about the front end. So we have all the HTMLs, the home, the reference, the login, the sign up. Each of them have their own HTML so that they can easily accessible HTML files without any complicated stuff. And along with that, each one we have the specific JavaScript files, the ones for the login and the ones for the sign up, and the ones for the devices and all that. These basically, for the login and sign up, they allow you to all the buttons and all that functionality, and they allow you to sign up and log in, of course. We also can see how when I show it with the incorrect stuff, it shows that we have a database that stores everything and checks with the database. It doesn't just let you enter anything to log in. Again, just a quick demonstration. So you see it's missing. So whenever you don't put an at, it will tell you that there's an at missing, and when you do it and try to log in, it will tell you that login failed. So it will show you that the login failed, and this just proves that we have a database present that stores everything you do, so you can't just log in with any random account or any random thing. So it have to be stored in the database first, which is done through the sign up. And this is basically just it about with the user interface and how we've integrated the front end. And now we're gonna briefly talk about the back end.
So let's talk about the code now. This is the sign up JavaScript file for signing up. Initially, it checks if the email and password fields are empty, and then just it posts the data, and then it tells you if it's been posted successfully. You get an alert that shows that tells that the user has been successfully registered. Otherwise, if there is an error or if the user already exists, then you get an error that just says there's an error. And now moving on to the login JavaScript file. Initially, it also checks if the fields are empty or not, and then it tells you that the password and email are required. After that, we send a post request to the server, and if there are any issues, you'll see an error in the console that tells you that the login failed. if there is an issue with creating the token, you would see this message. If it's all good, then login successful, and you'll be redirected to the devices page where you can see your devices. And finally, if your credentials are wrong, like your password or your email, you will see this pop-up message. So moving on to the registering process, routes. So for registering, initially, if the user has no devices, they will see this message, and then they will be prompted to create new devices. And if there are errors with the token authentication, the user will be redirected to the login page in order to log in again and generate the token. This is for adding new devices. If the name field is empty, there will be an alert, and then the process is very similar to the other functionalities in the code. It get posted, and if there are any issues, the user will see those. If there's nothing wrong, the new device will be added to the database. If the user decides to log out, the token will be removed from the session storage, and they will see an alert. They will be redirected to the login page. And this is just a process for adding the devices to the list, and also creating the showing the API key as well. And then this is the functionality for moving the button, the devices. They again it checks for the token, and then deletes the device. If there's an error, it tells you. Yeah, now moving on to the routes. So for the first one, it looks for the user based on a user ID. And we can also look at the models. So the user only has an email, a password, and a token. And we'll move on to the route for adding new devices. A name is required. If the field is empty, there'll be an error. And if not, a random API key will be generated and assigned to that device as alongside the name that was picked by the user. So we'll look for the device based on the ID, and if the device is found, you filter out the readings based on timestamps. And after that, if there is no reading, all of the parameters are 0. Otherwise, the average is calculated alongside the minimum and the maximum, and the data is returned. So let's move on to the route for receiving the data from the device for the sake of time. So in the beginning, we check for all the 4 fields that we expect, if they're valid or not, if they're missing. After that, we'd check for the device based on the key, the API key. If it doesn't exist, that means that the device is not registered. Otherwise, the new reading is saved. And then a message will say that the data has been recorded successfully. And lastly, we have the JavaScript file for the chart, and it fetches the data based on the device ID. And after that, moving on to the plot chart. We're using chart.js. This is what we're using for the plot. In terms of the device itself, This is the code. So all of these parameters are based on the example code that the library provides. This is how long, the amount of time between each reading. This can be changed, of course. Right now we have it at 3 seconds. And this is the maximum time for storage if there is no Wi-Fi. And it's of course 24 hours based on the default value. As there is no Wi-Fi, this is the value we're using. Every 10 seconds we're checking for it. So this is the functions, the setup function. It's just pretty much connecting to the Wi-Fi to the protocol cloud, setting up the device, checking if it's being detected. Here's the process of reading the data. Initially, we get the oxygen and the heart rate levels based on the delay, which is just how long we're waiting for each reading. And we flash after that amount of time has concluded. We flash the LED. It's a blue flash for 0.5 seconds. This is going to indicate that the user should input a reading. If the user doesn't input anything, none of these will execute. So we will loop back to this part right here. And these are just for checking the heartbeat rate, the oxygen level. And then after all of the readings are done, we will send the data in this format. This is the API key that will be checked. And then if the Wi-Fi is ready, if there is connection, we will send the data. If not, the data will be stored locally. Or it's actually this part. And this is just trying to reconnect. And then sending the measurements if the Wi-Fi is ready. And there is a loop that will check if the stored data has exceeded the amount of 24 hours. And this is just a function for the colors that were used: green, yellow, and blue. And that's it. Thank you.